and I will execute line 8 at that point. Line 8 is going to calculate what is the product between R and N and store that number back into R. R refers to column C. Column C at this point has a value of 1. N has a value of 2. 1 times 2 is 2. I store the 2 back into R. R is an alias of column C, and as a result, column C, or variable X, gets updated. Do we have any questions about this one?
I'm gonna have to try it myself. Sure.
Well, you have to kind of read the notes too, because you want to make sure that you understand what is an alias. An alias is just a reference to an item. When you update a parameter passed by reference, you don't change the alias, you change what it is referring to. Okay.
Why is it that you didn't go back to the last return line 8? You went back to the first one.
I went back to this one. I used this return line number to go back to this line 8 here.
Okay.
Is that okay? Okay. Well, we have multiple line 8s to return to, so that's why it is important to keep track of which one we're dealing with. Okay. You always use the most recently created return line number to tell you where to go back to. And when we got...
Put a 1 where right there?
What?
Let's put a 1.
Sorry?
8, where you got a 2, isn't this supposed to be a 1?
Not in
Oh.
Line 8 tells you to multiply R times N. R is...
This we are talking. Yeah, when we execute line 8 here, we are talking about this R and this N. So N has a value of 2. 2 times 1, because R refers to column C at that time, it had a value of 1. So that's why it's
the column J.
column J by this time is already gone. I can't use that context. Column J is only useful because it tells me to go back to line 8, and that's how I ended up here. But after that, these columns are deallocated. Okay. After line 8, we don't have anything else to do in the else branch, so that means we get to the end of the subroutine again on line 10. And just like every other end defined sub, we deallocate the 3 columns that we allocated earlier. And this time, return line number, or column G, tells me to go back to line 8 again. So now we go back to line 8 again, except the context is now columns D, E, and F. We're on line 8 of the pseudocode again. We compute R times N. R is also known as column C. Column C at this point has a value of 2. N refers to column E. Column E has a value of 3. 2 times 3 is 6, and we use that value to update R. Once again, R is an alias of column C. As a result, column C is updated to a value of 6. We doing okay so far? Okay. And after line 8, we get to line 10 again, which means we have to deallocate these 3 columns and go back to the line that return line number is telling me to go back to, in this case, line 12. What does line 12 do? Line 12 is just going to print the value of X. So we'll go ahead and say we are printing the value of 6 here because variable X has a value of 6. And now we are done with this trace. Does this trace remind you in a certain way of your previous homework assignment, subroutine 1? It does the same computation, but it does not need any global variables anymore. Okay, in subroutine 1 as a homework assignment, you had to use the global variable R. In this case, variable X is a global variable, but inside the subroutine, it does not have to mention X at all because parameter R is passed by reference, and that's our wormhole to get back to the original item. Is that okay so far with passing by reference? Yep.
Is there a time where an alias, like there will be an alias of an alias?
We don't call it an alias of an alias. We call it a pointer to a pointer, but you won't get into that concept until late in cisp360. So for all the practical purposes in this class, we don't have aliases of aliases. Any questions at this point about factorial passed by reference parameters? No questions about this? Now, I like this program quite a bit because if you just look at the subroutine itself, okay, the factorial subroutine, I have now completely gotten rid of global variables. Okay, remember why we want to get rid of global variables?
Safe space.
That's one aspect of it. What is the other aspect? Yep.
Make the code more intuitive. And it doesn't, you don't have to worry about other things modifying things other.
Right. Basically, if a subroutine does not access a global variable, you don't have to worry about the quote-unquote side effect of the subroutine. Okay? So what I mean by that is if you just look at the invocation of factorial, the line of the invocation tells you exactly what it can potentially modify. You can tell that n is a passed by value parameter, which means there's nothing that this parameter can do to anything that you own. But you look at the way we pass to R, you know that this subroutine can potentially change the variable x. But can it change anything else? If I tell you that factorial does not access global variables, and let's just say that you have 200 other global variables, do you have to worry that factorial may change one of the other global variables? You don't. Okay? And that's the whole point of getting rid of global variables in subroutines. Are we doing okay so far with the rationale of trying to get rid of global variables? Sort of? Yes? Sort of? Okay, sort of? Okay. If the answer is sort of, you just have to chant after me, global variables are evil. Okay? I should change the we should make a prayer, just so that we can remember, global variables are evil. We just kind of add it on the list of items that are evil, and we should not do. They are, okay. Global variables are evil, and so is copy, paste, and modify. Okay, so we have to add those two items to the list.
Misuse of go-tos. And misuse of go-tos.
Oh, I don't even want to talk about the G word. The G word is beyond evil. Now, just like all the other things that that the people put into the prayers, you will be tempted to use global variables. You will be tempted to copy, paste, and modify, and in some cases, you will be tempted to use go-tos. Just don't do it. Okay, it won't affect your afterlife, but it will definitely affect the maintainability of your programs, which is a very short-term kind of thing. The pain comes right here.
What's wrong with copy, paste, and modify? What's wrong with copy, paste, and modify?
If you write code always correctly the first time, it is not as much of a problem. On the other hand, if you make a mistake and you did not fix the mistake before you copy, paste, and modify, then now you have offsprings of the original faulty code, and there's nothing the program can actually help you to find all the offsprings of that original faulty code. Okay, so copy, paste, and modify is really bad from that perspective, because now you have instead of having one bug in your program, now you have replications of that bug everywhere in the program. And in a real programming environment, they may not even be in the same file. Okay, after 2 or 3 weeks, you would have forgotten where you have pasted that code all over the place. And that's one reason to use subroutine, so that everywhere you need to use the same logic, you just invoke the same subroutine. Now, I'm not saying that when you write a subroutine you cannot make mistakes. You can still make mistakes, but it's only one. You make the mistakes once, you fix the mistakes once. And that fixes all the invocations, because they're all invoking the same code. So that means every time you want to use copy, paste, and modify, you want to think and say, instead of copy, paste, and modify, can I turn this into a subroutine instead? Okay, because if you can turn it into a subroutine or subroutines in some cases, that means if you did make a mistake, you only have to fix it once and not to have to worry about all the other places where you paste that code. Okay? So all of those things, are things that you learn, when you write, longer programs. And I can almost guarantee that most people in this class will not truly realize the problems of global variables, copy, paste, and modify, and even go-tos in classes that you will take in a JC like this, or even in a 4-year university. Okay? Programs that are typically less than 300 lines will not have too much of an issue, but when you start to write longer programs, or when you try to maintain programs that other people have written, then it becomes a big issue. Yep.
I have this one friend who made this map editor for a video game, and he made it really terrible. It's so bad he doesn't even know what he was doing. So he can't even maintain it himself.
Yep. Well, I have the luck to have to maintain code like that I did not write. There was one single subroutine that had 500 lines. Okay. Now that all by itself is already really, really bad because my screen can only fit about 16 lines at the same time. So that means in order to go from the beginning of the subroutine, which lists all the parameters, to the end, I need 8 page downs. Okay, page down, page down, page down, page down, page down, page down, page down. Then I get to the end of the subroutine. But on top of that, it also had go-tos and also global variables. All the things that we are not supposed to do in programming, you can find it in one single subroutine of this program. And that's not the only subroutine that has that problem. It's just one of the benchmark or one of the poster child of what we are not supposed to do in this case. You guys know what I ended up doing?
Scrapped it.
Yep, pretty much.
Yeah.
I could not even track the execution of that subroutine. I try to do it by hand, in dry run, just like what we do in this class. You look at the code, and then you follow the code. Okay, this line goes to that line goes to that line. With go-tos, it's really hard to do. And then with global variables, it becomes even worse. Because when you trace a subroutine, you can make assumptions about certain things. Like in this case, let's just take a look at factorial. When you trace factorial without even the other portion, you can make certain assumptions like, let's just say that n is 2, okay? And r is really not important because we are initializing r anyway in this code. But when you have global variables and many of those things, then the behavior of the subroutine will depend on the values of the global variables at the time as well. Okay? And that's not easy to track because when you just look at a subroutine, you have no idea of what the values of the global variables will be when it does execute. Okay? Now the use of go-tos makes it even worse because you can jump from one point to another point of the pseudocode with apparently no reason at all. So that was a really bad program, or bad subroutine at least. So are we doing okay so far with passing by reference? But I still have one problem with this code. The problem that I have with this code has to do with line 11 and line 12. If my only objective of this program is to calculate what is 3 factorial and print it out, this way of doing things can still potentially give me a problem. A potential mistake can be made here. In other words, what if I use x here, and then instead of printing x here, I print y? Let's say we have another global variable y. Do you think a compiler or a interpreter